This video is for section 9-9 about compound interest, which is one application that uses logarithms. There are many formulas from science that involve logarithms, and I put some examples on the note page. In chemistry class, acids and bases are measured with the pH scale, where the value 7 on the scale is a neutral compound, but numbers lower than 7 are acids, and numbers higher than 7 are bases. The numbers on the pH scale are generated from this math formula here, which involves finding the logarithm of the concentration of hydrogen ions in a solution. One situation in physics that involves logarithms is the Tsiolkovsky-Rocket equation. There are other situations in chemistry that involve logarithmic equations. One is named after a scientist named Fensky, and another named after the scientist Nernst. You might know that the strength of a sound is measured in decibels. That's a logarithmic scale. And you might know that the strength of an earthquake is measured on the Richter scale, another logarithmic scale. Some of you have Miss Bannister for psychology class, and you may have encountered Hicks' law or Fitts' law. That has to do with how quickly humans make choices and how quickly humans react. Logarithms also occur in the study of probability and in music theory. These are just a few examples that use logarithms. Logarithms are also used to solve formulas that involve exponential growth or decay. Because the logarithm is the inverse of an exponential, it allows us to solve equations that have exponentials in them. The equation that we're going to focus on in this section is the compound interest formula equation, which you see right here in the middle of the screen. The variable A represents the amount or future value of money in a particular investment. The variable P is the principal investment or initial amount of money that was deposited to begin the investment. The variable R is the interest rate. When putting a number for R, make sure you put the number in its decimal form. For example, a 4% interest rate would be the number 0.04 for R. The letter N is the number of times per year that the interest is compounded. Possibilities include monthly, in which case you'd put a 12 for N, or perhaps quarterly, in which case you would put a 4 for N. If the interest is paid only at the end of a year, you would put in 1 for N. The variable T is the time and years that the money is being invested in the investment. And so if you deposit some money for 5 years and want to know the future value after 5 years is up, for the letter T, you would input 5. With this formula, you can analyze different components of an investment situation. Knowing numbers for all of the variables on the right side, you can figure out an answer for A. What's the future value of an investment? Or, knowing numbers for every letter except P, you can figure out how much money do you have to invest now in order for it to be worth a certain amount in the future. Or, knowing numbers for every letter except for T, you can figure out how long it's going to take your investment to grow to a particular value. The note page has some examples of these different situations. First example, find the future value of a $300 investment at 10% interest compounded monthly for 10 years. Future value is the letter A in the formula. $300 investment is the letter P, our principal investment. The 2% interest is the letter R, the interest rate, and that's going to be the decimal 0.02 when we actually fill the number in. The word monthly means that N is 12, and the 10 years means that T is 10. Let's use the formula and make the substitutions. So A equals 300, and then in parentheses, 1 plus, now comes the letter R, so 0.02, divided by, now the letter N, that's 12, and in the exponent, it's N times T, so 12 times 10. Observe that the unknown is the left side of the equation, so to get the answer, type this entire expression in the calculator and push enter. The result is $366.35. When solving this problem, we did not need to use a logarithm. Let's take a look at our second example. What interest rate is required? So the thing we don't know is the letter R. For a $450 principal, that's P, to double in value. So if we start with $450 and we want it to double in value, that's when A is $900. When it says 3 years, that's the value of T, and semi-annual compounding means twice a year, so N is equal to 2. Let's make our substitutions. For the letter A, 900, for the letter P, 450, and then in parentheses, 1 plus R over N, so the letter N is 2, and the exponent is N times T, so 2 times 3. Next up, we can divide both sides by 450. Getting 2 is equal to 1 plus R over 2 raised to the 6th power. How do you remove raising to the 6th power? You take a 6th root. So take the 6th root of this side and take the 6th root of this side. This makes the 6th root of 2 is equal to 1 plus R over 2. Now subtract 1 from both sides. So we have the 6th root of 2 minus 1 is equal to R over 2. Then multiply by 2 on both sides. So we get 2 times the 6th root of 2 minus 1 is equal to R. Type this expression on the calculator to get the answer. Remember, when typing the 6th root, don't use the square root button. Use the button that lets you put in an index of 6. The answer is R equals 0.2449. It's common to interpret an interest rate as a percent, so this is 24.49%. It would be an extremely rare investment to have a 24% interest rate. Investment opportunities don't usually have that high of an interest rate. When we solved that situation, we did not use logarithm. Now, third example, how much money must be invested now? That's the principal. So that you have a balance of $15,000, that would be A, in 7 years. That's the T. If the investment pays 4.5% interest, that's R, compounded quarterly. So that's N equals 4. Let's make our substitutions. It's the variable P that we do not know. For the interest rate, make sure you put it in its decimal form. 4.5% is 0.045. The letter N is 4. And the exponent is N times T, so 4 times 7, which is going to be a 28. Next step, let's figure out what this part here makes as a single number. When you type that in the calculator, it's 1.3678. Now we can divide by that number to get P alone. So type 15,000 divided by the 1.3678. On the calculator, this is $10,966.10. That's how much money you'd have to invest now in order for it to grow to $15,000 in 7 years. Notice that once again, we did not use a logarithm to solve that equation. So when is it that you do need a logarithm to solve an equation? It's in this fourth example, when the variable is in the exponent of the equation. Let's give this one a try. How long will it take? That's the letter T. An initial investment of 400, that's P. To triple in value, that means we want the amount to be worth $1,200. If the interest rate is 3.25%, so R is 0.0325, and compounded quarterly means N equals 4. Now let's make our substitutions. For the letter A, 1,200. For the letter P, 400. In parentheses, we have 1 plus now the R, so 0.0325, divided by the N, so 4. And for the exponent, 4 times T. Next up, let's divide the 400 away on both sides. We have 3 equals the 1 plus 0.0325 divided by 4 raised to the 4t power. Next, let's figure out what this number inside the parentheses is as a single number. So type that part in the calculator. 8125. And that's to the 4t exponent. The variable t is in the exponent. Here's where we need logarithm. Take the logarithm of both sides of the equation. Do the log of the left side and do the log of the right side. We have log 3 is equal to 4t times the log of 1.008125. In taking the logarithm of the right side, I've also applied the theorem from the other day that the exponent on this expression can be moved in front of the logarithm. To get the letter t alone, it looks like we now need to divide by 4 and divide by the log of 1.008125. We'll get t equals log of 3 divided by 4 log 1.008125. That's what you need to type in the calculator. When you're typing, be very careful to include that entire denominator in parentheses so that the calculator knows you want to divide by the 4 and divide by the logarithm part. When you type that in, the answer is 33.9 years. It takes a really long time to triple your investment. Let's summarize the lesson. We looked at 4 different ways to use the compound interest formula when analyzing an investment situation. If you take personal finance class in your senior year, you'll do even more with the compound interest formula.